All right, guys, let's get started. Content, contents. All right, so we're going to get started today. So on the agenda today, we're going to talk about homework assignments that are coming up. I've posted some, so you may have had a chance to look at them. I'll elaborate on what they are. Um, so, yeah, so I'll talk about them, and then we'll talk about reinforcement learning through human feedbacks. And we'll go over one example today with the TRL library, so the transformers for reinforcement learning, I guess it's called, from Hugging Face. So at this point, that example I can't unfortunately run in real time because it requires a GPU, right? So it's like I'm going to talk about it, and we are, before we were just doing inference, which we could do on our computer on a piece in a CPU-based computer. But once we start training anything that has a transformer in it, etc., it's going to require more computing power. So I did request the Scholar GPUs, and I did get an email back from them already. So hopefully we'll get that sorted out soon for you guys to use those machines. Okay, so far in this semester, we started with inference, right? So that's where we started, just trying to solve some problems or look at things. So the inference just means the model's already trained and we're just using it to do something. So the first topic was AI agents, right, that we covered. Then last week we started with the Hugging Face Transformers module, okay? And just also doing some inference there using models, etc. And we were doing BERTs. We looked at BERTs. We did some sentiment analysis, etc. So little things like that. So today we're going to look at the homework assignments, as I said, and then also reinforcement learning through human feedbacks, which should be this link. So the general pipeline for RLHF and some examples that I will provide. So I'll go over the discussion of that. And that's going to be a third homework assignment that you're going to do. Okay, then I will talk a little bit more about DeepSeek probably, as it's pretty important. So that's going to be tied. Yeah, so I'll change that. Okay, so let's talk about homework assignments first. So I think the first one should be here, right? AI agents. Let's click on that. So this one is due, I think, 2 weeks from today, right? It's available until February 20th. So that's the first homework assignment that you guys have. So in about, 2 weeks, 15 days. So what I want you to do with this assignment is pretty much what I did in class, right? So let's take a look at, so using the AI frameworks discussed in class, which I did 2 frameworks, Crew AI and Small Agents from Hugging Face, create an AI agent for use in a specific use case. Do you guys see that? So your use case refers to the task and job you want the agent to complete. For example, a law clerk that can review legal documents, etc. Right? Try to provide a metric that can be used to measure the performance of the agent. Just do some research and figure out, or make up a metric. It really doesn't matter. But just something that you think would be good. Use at least one tool with your agent. So I showed you guys that you can use tools. You will need to submit a report and present your use case in class. So I do want to see you guys do short presentations of what you did. Does this make sense? So you remember that you can grab any model like ChatGPT even, right? So I showed you how to use ChatGPT or Qwen, DeepSeek probably or possibly, right? And then wrap it around Crew AI or small agents. But you need to create the use case first. So you need to say what industry you want to work in. Let's say you want to be a law clerk or system administrator or cybersecurity and finance, whatever it is, nursing, whatever it is, create a use case and then build the agent for it and use it with a tool to try to solve some task and of course try to measure some performance. Does that make sense, guys? Do you guys have any questions on this assignment? Yeah, please.
Or that we use the platform.
Well, I provided Crew AI and small agents. Do you know of another one? Another AI agents framework that you want to use? Yeah, so that's the idea, right? So a model is something like ChatGPT or Quen, but you want to make it into an agent, you need to have this functionality of using tools, multitask, although I didn't say there, you could have, two agents where one does one thing and then passes it to the other. Do you see what I'm saying? And try to be creative. As if you were going to sell it, try to like sell it to, somebody in the restaurant industry, take orders over the phone, and you have this agent that you're trying to build and try to make it so that you could sell it. You know what I mean? Like it's something interesting. Still, we're just doing inference with this, but this is really powerful things. You've heard probably that ChatGPT now they put out the research, deep research, I think it's called, and it's an agent that essentially can do research and scientific research, I suppose, but it's an agent just using a trained model. Are there any questions on this homework assignment? So you'll submit some kind of a report, with screenshots of how you did it, and then you'll do a presentation around that date of February 15th. Got it? All right, the next one that we're going to look at, so that's homework assignment number 1. So I'm just trying to give you enough work. And really, it's just going to be these 3 mainly homeworks related to LLMs. Then we'll do some related to images and things like that. But this is the first one. The next one is, so homeworks 2 and 3 are actually related. Last semester, I did it as one single homework, but I decided this semester to break it up into 2 so that you see exactly more detail about it. So I think it's here. Yeah, so I added this. So if you remember, last week we were talking about, I introduced the concept of transfer learning. So I gave you some of that text, right? And in that description. And I also started playing with, transformers, either GPTs or BERT models using the Hugging Face library. So we started to do some classification, if you remember, right? Like sentiment analysis. And I started talking about how this could be used for rewards. Do you remember that? So that's what the homework is going to be. You're going to just find a BERT model that could be used as a reward function, right? But I want you to do 2 types of rewards. The one that already does the classification or the one that we call the 0 shot, if you remember. So I just want you to play with that. And then later on, you may choose to use that in homework 3 or not. Okay, so let's read through it. And also this one, so this one will be due a week from, so on the 27th, so in 3 weeks from about today. But this one is a much easier one, and like I said, it's part of the main homework on RLHF. So let's click on this one to read through the description. All right, so this one's a little bit more verbose there. But in class, homework number 2, in class, we discussed that generative LLM models, GPTs, can be fine-tuned by providing reward values to the GPT based on generated text. This is called reinforcement learning. These reward values can be generated using a second model, such as a BERT classifier or a 0 shot model. In this homework, I want you to imagine that you want to train a GPT model to generate text that sounds more like text associated with a specific condition, environment, or goal. So for instance, you want the text to be less toxic, more funny, more charismatic, etc. You just want to shift it. And I'll show this to you today. So that's the topic of today, the whole pipeline. So, but you're thinking about that, right? So to fine-tune this GPT model, you would need a reward function that can provide the necessary feedback. So there's going to be 2 models, a GPT generating text and then a reward function providing the feedback. Okay. So this assignment too is just about the BERT model. I want you to focus on that. As such, I want you to find and test two models that can act as a reward model. One model A should be some type of BERT classifier. So you literally just have to find a BERT classifier that does some task. And the other B should be a zero-shot type of classifier. So this is like the example I did. So I want you to kind of try this out as well. So you can use Hugging Face for this assignment. You will need to submit a report and present your results. Okay. And I think this homework will make more sense after today's lecture, right? That you will need to find these reward functions. But I want you to try both. Like, you have a BERT classifier and then you have a zero-shot classifier. Test them on a task and see how well they perform and see if one could be better than the other. Got it? All right. So those are the two homework assignments. Start working on them and just ask questions if you have them. Okay. So everything clear, or is there anything that sounds confusing? All right. Sounds like you guys get it. All right, great. So the topic for this week is reinforcement learning. So I'm going to go over here. So now, this is week 4. So for the first 3 weeks, all we've been doing is doing inference, right? So we've been, using models as they are to solve problems. But now we're going to look at the case where we actually want to modify the model, right? So this is called fine-tuning. We take a pre-trained model and we're going to fine-tune it to a specific test. All right, so that's the next step. So that's going to be this module here, RLHF, so reinforcement learning through human feedbacks. Okay, so I have a few examples. Add one more link. So this is the transfer learning, 530 GitHub. If you notice, I've added this little module here. And this is kind of the things that I want to cover, right? In this in this section, this sequence. Today, I'm just going to focus on this example with spam. All right, so we're going to take a look at that and just think about the general ideas of how we can modify a GPT model to be better at a specific task. So let me just add this link. This TRL. So now that I have that. All right, so what is the general pipeline here? So the general pipeline here is that you have some GPT model, pre-trained, possibly even fine-tuned. So that's perfectly fine. But then we're going to do further training of it, okay? And so there's the pipeline for this says, take the GPT as is, the pre-trained model, maybe fine-tuned by someone else, and then you start your own pipeline. The first step that you can do is something called SFT, which is supervised fine-tuning. Okay, just no reinforcement learning, just essentially like the way that we train a classifier. We give it data, it predicts, we have some metric. So after supervised fine-tuning, then we can apply this process called reinforcement learning, okay, which has, it's an area of a mechanism where models produce an output, that output, that action is measured, right? And the model receives some kind of a reward. And then based on those rewards, the model tries to optimize the rewards that it's getting, for instance, until it improves its performance. All right, so So we'll discuss that later on. And this is the technique that is used for lots of things, like it was first used to align questions and answers. So you had something like GPT, GPT-3, GPT-4, which was good at generating text, but it was not great at answering questions. So then you use reinforcement learning to improve its ability to answer questions. This can also be used for solving math, as you can see. So this is a simple example of math. This is not what DeepSeek does, the chain of thought, but this is still trying to solve math and so on. So the example that I'm going to do today is this one, RLHF spam. And I have the Jupyter notebook here, okay? So this took me a little bit, it was a bit of a challenge to do this one. And I'll talk to you about a lot of the technical things required to do this, okay? So the only way that you can do this, Jupyter, is with, like I said, with a GPU box. So you'll have to use your Scholar GPU. So I actually have two versions of it. I have this version here. And I have this shortened version here. So this is implemented using the TRL library from Hugging Face. So we will go over the basic mechanism on how to do that. So I would like, so currently today, everything is through these libraries. So there's a lot of abstraction going on. I wish that we could do this like in pure PyTorch, and it's something that I'm working on, but I don't have any code right now that can do reinforcement learning through human feedbacks in pure PyTorch, right? So instead, what we have to do is we're kind of stuck with these libraries, okay? And I'm not criticizing Hugging Face. I think they're great. But there's a lot of abstraction going on, so you may like it or you may not. So anyway, this is what I'm going to use today for the demo. And you can see here we have this library called TRL. So going back to, but before we do that, so going back, the classic example of this actually is the RLHF sentiment. Okay, so this is also, they're both very, very similar, as you will see. And the idea is that you have a model that generates text and you just want to make that text either be more positive or more negative. Okay. So let me go back to the repo. So I'm going to click on this. Okay, so here I have an example. And then we're going to use this. This is like the basic entry level example, which I like. It's probably the best one to start learning these ideas. And then my repo, where I have a whole bunch of examples. All right, so what are we going to use? So the thing we're going to be using is this library here, TRL. So I'm going to go to Hugging Face. So this is the library, okay? So it's from Hugging Face. Just like they had small agents for AI agents, they have a library for reinforcement learning. Okay, this will have all the algorithms that you want to use. So they have these algorithms that you may have heard about, like DPO, GRPO, PPO. So these are all the implementations. And we'll talk a little bit of the theory as we move forward, okay? As this is, this will take us a little bit of time. So today I just want to give you the overall pipeline of using the TRL library. Okay, but they've implemented essentially all the algorithms, all the math into their library. And I'm using the examples from here, so these are the same examples. So if you want to read through a lot of information, you can read through this. All right, so let's start then with the classic sentiment example. And then we're going to get into the spam example that I did. So this chart here, tune a GPT-2 to generate positive reviews. Okay, so this is essentially the main idea. Okay, you take a GPT model, and in this case, we can take something like the GPT-2 for IMDb. So it's already fine-tuned a little bit to generate movie reviews. Okay, so it's not just a GPT-2 from scratch. It's a GPT-2 that has been further fine-tuned to generate movie reviews. So you have a working model, you give it a query, which is this movie is, and then it's going to provide a response that says really great. So that's what the model does. Okay. Now, what you want to achieve is you want to create a framework that is going to make that text become more positive or more negative. So you would want the GPT to be more critical of movies. So, for instance, the movie is really bad. That makes it more negative. It's still providing reviews, but they're more negative. Or you can make it more positive by saying, this movie is really, really nice. I really liked it. So it makes it just more positive. That's all we're doing. Okay. Does that make sense? So the way that it works is you have the GPT, and then you're going to have a second model, such as the BERT model, which is kind of what I'm asking you to do for homework too, right? Get one of those. So the BERT model is critical here. Now, you could, of course, take a BERT model and fine-tune it for a specific task. But that's not what I've asked for the assignment or anything like that. I simply, at this point, want you to take a BERT model from the Hugging Face hub or do zero shot and train it like that a little bit. So what happens during RLHF is that you're training the model, you're giving it queries and responses, and then those queries and responses are being concatenated together. So the movie is really great, and then they are given to a model, a DistillBERT in this case, or a BERT. And this BERT, of course, is a classifier that is going to say, some class, but it also provides the logit, right, which is the probability of that class, as we discussed in the previous lecture. And so that's what serves as the reward. Do you see that? So you give it query and response. The movie is really great. And then you have that goes into the model. The model provides a reward, right? So it says it's, 0.7, 0.8. And that signal is what is used as a reward to adjust the weights of the GPT-2 so that eventually when it's done, you get it to become whatever you want. And that's essentially how it works. And it works well, okay? So that's the key idea, the key insight. And of course, there's the math of the algorithm, which we will discuss in a little bit more detail later on, okay? Any questions on that, guys? That's essentially like I said, this can change. So for instance, DeepSeek, according to them, when they did what they didn't use a second model. This reward function, according to their paper, is just heuristic based. That's based on rules. So who knew, right? Before their paper, this was the state of the art. At least that's what people thought it was. Anyway, so regardless, this is what you guys will do for your homework, okay? So you will need a couple of models. So how are we going to do this? So this example, as I said, this is the sentiment analysis example. And you can see it seems like there's a lot, but it's actually shorter than you think. At the end of the day, it's a lot of training there. Okay. Let me see if I can just scroll down. All right, I really like this table. This shows you exactly what has happened, right? So you have a model. It's using a BERT scorer to provide the reward signal. So think about what that function does. The reward signal just takes some text, looks at it, and maybe you're trying to make the text more positive. So it's just going to look at it and say, yeah, it's positive with 0.70. and it looks at another one and it says, oh, this one is positive with 1.5 score. This one is positive with 3.2 score. Do you see that? So it's always providing, and it's telling you the level of how positive it is. So not only, so this can be used in two ways. During the training, it can be used to basically provide the signal for the reinforcement learning algorithm. And also, once it's trained, you can go in and look at predicted text and provide a metric of how positive you think it is, right? So that's what's happening here. So if you look, this is the query, right? When originally screened in America in 1972. So that's a query. It goes into the GPT, and the GPT provides an answer such as a fair, or it provides, so this is response before and response after. So before is just the model as is, right? And response after is the model after the reinforcement learning. Do you see that? So to make it more positive. So in your homework assignment, this is the thing. When you do your presentations of homework 3, this is what I need to see. Okay? This is like the critical thing. So the goal is, obviously, if we're trying to make the text more positive, these should read more positive. But additionally, we have a way to measure that it's the performance, because the score gives, we apply the reward function to both the text before and after. And if we're focusing on positive, then this score, as it goes up, it basically means that it's more positive as well. You guys understand that? And so that's the key thing with this assignment. So I really like this. I think talking about reinforcement learning, I really like these examples because it shows you exactly what's going on. So now let's take a look at it. So this is just a few examples, but let's see. Vampire City, I guess. Borgs and suggestive dead person's flashback. That's not positive, right? You would agree that that's actually a little bit towards negative. Now we look. P.O. is a wonderful movie, envious character. So you can see that as you read it, it's become a little bit more positive. Do you guys agree? Yeah. So that's essentially what has happened there. And then when we look at the score, you can see for the first one, it says it's 1.13. For the second one, it says it's 2.82. So actually, we have a metric that says that it is more positive. Okay. So that's how this works. And then we can look at another one maybe. Okay, this one's both positive. And you can see here, for instance, yet another forget, suggesting it has a fantastic effect, and about this is a great movie. So you can see both of them are kind of positive and close to each other. Whereas you can look at one, maybe this one. This one is highly negative, the first one, and after is highly positive. So where to get it, I forget it, they inked Warren Beatty. Somehow it thinks that's negative. And then over here, where to contact, it is a masterpiece. So yeah, so it's more positive, essentially. Okay? So that's what we're doing with RLA, with reinforcement learning. We're trying to take a GPT and just shift the weights in such a way that the text that comes out is more like what we want it to be. So this, as I said, has been used for chain of thought. This has been used for math problem solving. And initially, it was for question and answering. Okay, so you give it a question and an answer, and you want it to say, the GPT got a question, it provided an answer, then another question and another answer, and you could say which one was more like an answer to that question by just providing some feedback. Now, of course, we don't have reward functions for everything, so sometimes that has, if we don't have those, then that has to be done through human preferences. Essentially, a human rates it, but then once you collect enough of that data, you could actually train a BERT model to do it. Do you guys see that? All right. So that's it. So does this make sense? This is the homework number 3. Okay. So now how do we do it? In this example, as I said, it'd be nice, and I've been working on this to make this in pure PyTorch. I've not been able to crack that. So currently I'm kind of stuck to TRL. TRL seems to be the library that's the most powerful, or most common at least. So that's what I'm going to do next. Now I'm going to break down into the code. This is the code I went over for the example today. We can try to run some of it, but it's not everything will run, unfortunately. Okay. But I'm gonna walk you guys through it. And the training won't run. And we need a GPU, and I haven't gotten the GPUs yet from the university. All right, so give me a minute here. I'm going to start that process.